Our first patient tonight is this beautiful tiny little thing with AM5 socket. Those little boards actually have a really good success rate. It's probably mainly because no warping and stuff like that, but also easier to heat up, just smaller area, the entire heater covers it. So usually these go well. We have an outline on the socket, so it should be easy. However, this one took a lot of heating, a lot more than I thought. Now I did a cold start of the heaters and preheating slowly, about an hour. So our standard procedure. Everything is going well over here, and as you can see, there's no warping of the board because it's nice and tiny. Now the top heater kicked in, and yeah, and I keep testing, and look at that. The very last few seconds of the last step, and I can feel that I could pull it from this side already, but I wasn't too sure, so I figured let's try on the other side, and that's when it released. So like barely, right? So the entire profile was barely enough to release this socket, which is a little unusual, but again, small boards, usually thicker boards, and that takes a little bit more heating. But it worked perfectly fine. Obviously no ripped pads or anything like that, but that never happens. AM5s are a lot easier for wicking because you don't have to worry about those caps inside, so this is a lot more pleasant. But there you go, nice and clean. Now I've this batch of flags that I'm using over here. It's pretty potent, so then it takes a little while to clean it. I mean, again, just hot alcohol and, soaking and a few minutes of ultrasonics. Looks like it dropped at very low temperature, like 195 or something like that, 192 when it started dropping, and it finished dropping at 200. So it's dropped early. I think this was leaded solder socket, but it kind of depends how you preheat the board. But it looks like it cleaned pretty nicely. Everything went well over here. Looking good. Next patient is another tiny one, but on this one, well, the damage to the socket is not very significant, but the socket has no outline, and at this point I don't see it. Right, I didn't notice it yet, so I started preheating without outlining the socket. Now on these sockets with no outline, you can kind of see that internal outline, and one board that I messed up, the customer wrote me back like, well, why didn't you align it? I can see the outline, right? The outline is there, but yeah, once you put the socket on, you don't see that outline anymore. So that's the whole point. So that's why we do this, right? Just mark it on at least on 4 sides, and that helps a lot to align it. There's a way of aligning it left to right without an outline, because you can kind of see that line from this perspective, right? So when you look at the side, at the angle on the socket, you can see the internal outline, and you can use that for left to right alignment, but not top to bottom. So you can't align it. If you forget to do the outline, there's no way to align it. And even with the outline, it's the success rate is lower, is significantly lower, because now look at that, the socket releasing, is it releasing? Yeah. At the end of the, and we haven't even heated up all the way to 18. So this one released very early, right? So it's not holding very strong, which is usually a good sign, because that means it's going to be easy to wick it and everything. But you can't damage the outline you just made. And on the one hand, on the other hand, you want to get rid of that outline after you're done, right? So either the outline is going to disappear by itself during this, during wicking and cleaning and stuff, and then you can align the socket, or if the outline is strong enough to remain, you can't clean it. So it's kind of like pick your poison, right? So in this case, I mean, still with the custom outline, you still, you know, it kind of looks like it's aligned, and I think this one aligned well. I think this one is gonna work, but you never know. This is just an outline made with a Sharpie, essentially. But that's all we can do. Hope for the best. As you can see, it didn't clean all the way, so you can tell that the outline was there. I mean, it's not visible once you put the bracket back on, as like so, right? You can't really see that, but the outline didn't go all the way away. The majority of it did, though. I think alignment is good. Let's hope for the best over here. That's pretty much all we can do with this one. And the final guest of tonight is this beautiful board. It's essentially a full size. Yeah, it's a standard size. So this one will warp a little bit. And the socket in question is 1851, and actually the customer provided the socket, which I always appreciate when you guys send me the sockets, especially unusual ones like 1851. I don't keep a lot of these in stock because they're a lot more rare. It's mainly 1700 and AM5. 1851, yeah, I would say a lot less common. So that's awesome when I receive them, and sometimes I do even less common sockets. And usually I also receive them, but I do have a few of very rare, like 2011-3 and stuff like that. I have some of these, but obviously with these, the main issue, I guess, is the cleaning afterwards. This one has a very good outline, like excellent outline. It was sitting a little bit on the right line and a little bit on the bottom line, and bumped away from the left line and from the top line. So you just kind of have to make a mental note about that, and when you're aligning. But nothing really went wrong over here, and as you can see, it didn't. Yeah, now it popped off, right? But even the board didn't even warp that much, a lot less than they normally do, which is great because that's gonna improve the success rate on this one, or at least probability. And as always, the wicking is a pain. You don't want to move the caps. You don't want to have the solder blob go to the caps. You know, that happens sometimes, and it's a pain, because then you have to essentially remove all the caps, clean the board, replace the solder, replace the caps. That's a lot of stuff. And as you can see, I dropped the solder blob onto the socket provided by the customer. So that is very too bad, because these sockets are relatively expensive. They're like 20-25 bucks, something like that. They're not as cheap as AM5s, and they're even more expensive than 1700s. Well, obviously they have more pins, a few more pins, but it's essentially the same socket. It's just a little larger So that was too bad. Luckily, I do have, I had one 1851 on in stock. So at least there's that, because if that happened on some kind of socket that I never carry, right, something very unusual, I would have to order it from China, and that would delay this step by at least 2 weeks. That would be horrible, but luckily I had some in stock, and I learned from this never to put the socket where I put it last time. And usually I don't. Usually I put them on the fume extractor, so it's like kind of away from everything. But for some reason I put this one on the way where, oh look at that, it dropped very early. I put it in the wrong place, and I paid the hefty price for it. It took a lot of cleaning, but you wouldn't tell. I mean, you would tell under the microscope, because you can still see a little bit of residue on the caps and stuff, but I didn't want to overdo it with ultrasonic cleaning. This one took a lot of ultrasonic cleaning. Not sure why. And also, at certain angles, you can probably see it here, at certain angles you can see a little bit of discoloration, something like that. So if this was a whiteboard, you would see this would be a lot more prominent. So it's kind of the same problem we had on that one whiteboard, that it just wouldn't clean. It wouldn't get clean after soldering. That has something to do with how acidic the flux is, but also those coatings can be different. But here it is, it should work. Thank you guys very much for watching. I do appreciate you, and I shall see you guys in the next one.